Okay, my friends, it's Roger once again, Mud Fossil University, talking about climate change, and I can use those words because nobody can fire me. They made this guy stop saying that word, and then they demoted him or whatever they did to him. He couldn't use the phrase climate change. And call it whatever you want. But I'm going to tell you one thing right now. We are in the midst of being invaded by a ton of extra electrons. And I can very, very, very certainly show this. Alright, this video is going to run long for what I do normally. So I made a little collage of the light experiments I did with Rodney Warren out of Australia. And here's what he did. He shot, these were all taken by Rodney Warren. He came up with this Venturi slit. This is a single slit Venturi. It's two round metal drums. And it forces the light to crush into itself, creating plasma and all of the effects we see. And I'm going to explain to you what I think these are. That is pulse red laser from the same light I have here. Hold on. From the same laser, this one right here. Just like that. Bosch GLM 15. Now, he had the metric one. This is an American one. But anyway, it's just a red laser. Zip, 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 zip. Now, but it pulses and then it returns. Now, this is concussed ether. All these particles are electrons. This is accelerating this wave, which is not a wave, it's a particle, and you can see the particle in this shot leaving the wave. It's accelerating away from the wave and exploding at the Venturi, concussing its neighbors. And obviously re-radiating. All that is re-radiation. You see that? That's reverse EMF, electromotive force. These are what they call Higgs fields. This is Cherenkov radiation, which is a high intensity plasma, white Cherenkov, glowy radiation. All right? And they use it. You see them in nuclear water, the heavy water, and so forth. Now, these little spits of white, little sizzles of white, are what they refer to as bosons. And at the end of the boson, well, at the front of the boson, really, is the spinning field that follows the spinning charged particle. You see them? Bip, 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 bip. And what it does is that it goes like this. These are charged particles that are following its lead in the center. This is only in the center of that. Now, in a second or two, boom, it stops. Only 2 hits we see of that. And up in here, just to show, it's not on here, but up in here, there was one that came out of here is not like this. It came out as a little tiny white one, just glowy, but you could see the trail, and it never turned into one of these. It's the only one, and that is right here. All right, you see that? It came through, and then it concussed with a normal Higgs and did this. So we need to look at that. It's the only event I saw like that. And Rodney and I went over a year of doing this. And I mean, when we get into stuff around here at Mud Fossil University, we don't let up until we're done. This is what Rodney picked up. Look at this. Now, that's what I'm saying was these back-to-back dipoles. This is an electron here, and that's an electron here. One of them is this way, one of them is the other turned around. Here it is again. Now, it's showing itself now because it's in the process of a major amount of concussion. That's what I'm taking away. You see these spikes? It's banging into something. And then it starts to flatten out, and then, I don't show it here, but it starts to lay out at 2 little stripes. And this is where the boson part shows up in the center spinning, and these are the fields that are following the particle as it spins. That's what I'm taking away from it. I could be wrong. I have dozens of videos showing this in great detail. I'm going to show you one more shot, and then we're going to go into the other stuff. Into the rest of it. I mean, I don't know. It's going to be things I'm going to show, and things we're going to talk about, and things that are going to be about electronics, electricity, light, lightning, static, everything. Sprites. Sprites going to be huge, because those are the emissions from our Earth. They concuss with our ionosphere, just like it was, people say, oh, it is a firmament. Well, you want to call it? Good, that's a firmament. It is a ring around our Earth of dense electrons. When these electrons shoot from Earth, they explode into them, and you will see that in great detail. All right, now this is a fabulous shot. What are we seeing? Let's start right up here and take this layer above the impact zone. All right, you see that coming up? That is an impact zone. You say, well, what's this, Roger? That is the re-radiation down, because here's the deal. You have an ionosphere. All right? Ionosphere just means the heaviest concentration of ions. Ions are electrons. So here's where all your electrons are clustered up here, where the sun originally sort of cascades them into it, and they drive them in here, and they have a ton of extra electrons. So what happens here? At the Earth, we got some extra electrons down here, so we want to get them out of here. So they shoot them up, and they spam, and all of a sudden they say, whoa, what happened? I just slammed into a barricade of electrons, and they glow like hell because these guys are coming up making them glow like hell. Well, now you got so much additional electrons in, so you go, all right, you get the hell out of here, and they come back to Earth. No other possibility could you possibly explain that in any other way. All right, we're going to get into a little deeper, but before I do that, I just want to tell you, this is where it comes out of the accelerator, where it crushes it, and it's all in plasma, and it comes out, and then it settles down to these two particles. I'm just going to go over real quickly. The first particle displays these spikes, like it's really concussing and creating that. The second display of it, you start to lose the spikes, and it starts to flatten out. The third event of that particle is this. So that's how we see them settle out. We'll talk about that in detail later. Hello, my good friends. Roger once again, Mud Fossil University. Today going to explain the unexplained, and easily, by the way. Electron flood theory explains everything there is. Everything. Zero is unexplained in the material realm. Now, what is electron flood theory? There is only one particle that exists anywhere in the universe. It is the smallest particle, which I believe is the electron. It is this tiny little weight atomic mass unit. And these are dipoles. They're little balls. They're an electron, has a positive and negative, just like this. Boop, magnetically attracts to other ones, and they attach into zones of stability, which is approximately 1836 protons. Now, and of course, then you have the other little particles out here that want to get in there, but it's already satisfied. There's so many particles glued together here because only these exist, these particles. There's no big chunks. It was never a proton that was a big proton. There was 1836 little bits together, which were electrons, made a proton. 1837 or so made neutrons. These are averages. When they figured them out, these aren't solid numbers. These are averages because matter splays out all across the numbers, and we're going to go into that. Isotopes are just extra electrons. They're just more and more electrons in between zones of stability. S-orbital atoms are anti-gravity. There's not enough electrons, negative particles, to get pulled to the positive Earth. They are anti-gravity. Hydrogen and helium, because they only have s-orbital electrons. They're too light of negativity. That's what they're light of. You could have some big gigantic thing and it's still positive in relation to the Earth, and that's still going to go up in the air. You have to have more negativity in the body to come to Earth. And the more extra electrons you have, the harder it hits the Earth. And additionally, I say electrons are intelligent just like ants, because if they can glob together to make a proton, a neutron, an electron, an eyeball, an ear, a toenail, that's intelligence. Because one day they're inside of a plant, the next day they're inside of your stomach, and the next day they're growing out of your hair, out of your beard or somewhere. I mean, that's just the way it is. The same particle, same little bit. It just got rearranged. We're going to look at sprites in a second, and a sprite is an ejection from Earth of particles going up. Now, what is an electron and what is an atom made of? Well, electrons are plus and minus together, just like I talked about this. The core is just like this. All of these particles are pluses and minuses, but there is a zone of stability where this will have enough electrons trying to get into it. It becomes fairly stable with these neighbors. Now, what's an isotope? That is, so in other words, that's going to be one of these elements. It's a zone of stability. There's just the right numbers. It's like not too hot, not too cold, just right in that spot. But there is hot and there is cold. Those are the isotopes. So what is an isotope? It's nothing more than an excess particles that are hanging out on the edge. They shouldn't be there. So what happens? They are the ones, isotopes and the outer orbital electrons we have, they can sort of move around semi-freely. They create the flow of electrons, electricity, static electricity. They're extra electrons sort of hanging around. And if there's so many of them, they can become radioactive. Just shoot out of there like crazy. There's just way too much. Something just jiggles it a little bit, and this guy snaps and that guy snaps, and the whole thing goes and shoots something off in a very extreme manner. Now, this is what's called an electron flooded isotope. Electron flooding is everything, because everything there is electrons, 100%. And you could take another one of these things, and it's going to come over here, and some of its electrons are going to hook in with this guy's electrons, and that's going to become a molecule. And then another guy will come over, and he'll hook up with some of this guy's stuff, and then they say, well, what do you want to do? Well, let's become an eyeball. The guy needs an eyeball. Whatever it is, I'm telling you right now, it's all programming, and the things that I'm turning up as it gets deeper and deeper, it's just absolutely stunning. It's a programmed world we live in, my friends, and the particles know the programs. And right now, we got an issue with the number of particles that are in our space. So you say to me, well, Roger, why is it a problem? Well, we saw what happens when you have extreme amounts of isotopes. And what is an isotope? It's extra electrons. What happens? You could get radioactivity. You could explode right out of there, like this. So what does that mean, Roger? Well, that means maybe our Earth has too many electrons. Maybe it is flooded with electrons just like this is flooded to excess. Now, I can't see any way of mitigating the sun's emission of electrons to us. So whatever we do, I'm afraid we're going to do more damage than good, because I think they are messing with our atmosphere. But these are emissions from Earth. That's going up. That's not coming down. And they all of a sudden, here's what happens. Let me explain this about sprites. Sprites there'll be an excessive amount of like static electricity, just like you get on your body when you walk across a carpet or something. And these happen from weather systems, cold hitting warm, and a lot of violent interaction between the electrons in particles. There's nothing more than electron and electron. Every single action there is electron to electron, push to push. And then at certain points, they become pull. When you add them together in their core, they start to pull. And the more balls of stability, the more pull. Those are what we call the quantum. And that seems to work. Quantum I have no problem with. To speak of. There's several little issues here and there, but it makes the most sense to me. So anyway, what happens is you get this static effect here from these weather systems, usually thunderstorms and so forth. But it's because thunderstorms is usually down to here. Well, this time it's going up. We got too many electrons on the Earth in certain areas. Now, is it strictly in that certain area? I'm trying to find out if it happens over and over in the same spot. And I really don't see much about that. But it just happens primarily they're weather system related. Let's just go with that. And that makes sense to me because weather systems have interactions on the atomic level, pushing and so forth each other. And I worked in the electronics industry my whole life, and I was a troubleshooter. I was a field engineering manager for Victor Business Products. When they were a global entity, they were a powerhouse, and I had to figure out why this stuff didn't work when it got on the street, and it didn't where there was static. And static is nothing more than electronic discharge because you got too many electrons in one place. Just too many. Just too many. Just too many electrons filling in all of this area in here. There's supposed to be a certain number and you have a zone of stability. When you flood that, literally you have heat. More electrons you put in is heat. And they will create isotopes. And mostly they'll just float around in here and the isotopes are built already based on a nuclear core. Because the nuclear core is what builds the isotope. But then you can flood this thing with so many electrons that they have to escape. They have to escape. And this is what happens. They discharge out into space. Now that's not the way it's supposed to work on Earth. Earth is supposed to be the attractor, not the repulsor. And my feeling is, and I don't know, think about this in your own mind. If all this stuff is coming from the sun, these electrons, and I say it is because heat is nothing more than electrons, sunlight is nothing more than electrons, light is nothing more than electrons, that was nothing more than electron to electron. Everything is electron to electron, and these electrons come all the way from the sun down to the Earth. Here, you want to see something? Yeah, I'll show you my little, I got to show you this before I go over there. This is the little shop of horrors. I'm in the middle, look at this. I'm in the middle of changing all these little whiteboards based on the new, some of the new information. Anyway, here's what I'm saying is happening. All right, from the sun, all right, the particles are going over. They're particles. Now that is their trajectory, but they're particles. When they interact with the atmosphere in our Earth's atmosphere range, they smash into them. They're particles smashing into other particles. As simple as that. And the other particles are already residing in zones of stability, which are the gases, nitrogen and oxygen and so forth. And they're pretty stable to a degree, and this light is smashing into them and glowing. We see it glowing blue and, different colors, and as you see those little colors at the bottom. The reason the colors at the bottom are because the power is extreme coming from the sun. When it bounces off the moon up there on the left, that's re-radiated, and you can see, I hope you can see that little squirrely thing there, is a lot longer frequency. But the original frequencies, some of them could be long, some of them could be short. It sends out radio frequencies, it sends out all kinds of frequencies from the sun. So my point being is that we are absorbing them as particles. If they're coming as particles. We are taking them in as particles. You saw what happens to an atom when it has too many electrons, too many ice particles. It becomes radioactive. It emits. That's what's happening right now. In my world, that's how I see things. And this is why light sets up the interference patterns. It's not like a wave sloshing this way. It's a spinning particle. And some of them hit over here, some of them hit here, some of them hit over here. I mean, you gotta admit, this is cool stuff. That's amazing. Now, there must have been, you can see this like layer here. You can almost see a white, creamy layer underneath the bluish layer. And this is the leading edge of some major weather system where you have hot and cold clashing. Transfer of electrons, hot and cold. When you got hot and cold, you got a transfer of electrons. No question whatsoever. Absolutely zero. Hot and cold is nothing more than one will move to the other, and what is moving is electrons. I mean, it can't be any more obvious than that. That is extreme glow of high energy electron output. I don't care how you cut it. Every time you see energy like that, it's electrons forcing other electrons to get the hell out of the way. And what are they doing? They're being pushed away from Earth in this particular spot. Now, is that the center of a cloud cluster? I don't know. But the ISS space station is looking down, seeing this from above, and saying, oops, look at that. Now, this is a fellow named Chris Holmes who was flying at 35,000 feet, apparently, and photographed this. That's an extreme discharge into outer space, sending electrons away. I can't see any other possibility other than the atmosphere up where the electrons are cascading into us from the sun has filled up the available slots. And now it's really excessive. That's what causes global warming, because the only thing that ever will heat anything is if you push electrons into it. And you can do it chemically, you can do it magnetically, you can do it, by combustion. All of that stuff is the same thing, just in a different form. And this is nothing more than you got too many electrons here, get them out of here, they all start to discharge. And once you create a pathway, that's what's called a threshold. Once you reach a threshold and you have a discharge, this is nothing more than like a Zener diode to space. A Zener diode is a one-way, all diodes are one-way, but a Zener diode has to reach a cascading threshold, which means, and we used to use them all the time to establish different voltages, 12 volts, 16 volts. We had all kind of different things. I had a couple of different electronic businesses I owned, and I also originally got started, and I might have said this before, with Victor Business Products, who was a global entity. They were big, and I was the field engineering manager and had to figure out how things didn't work when they hit the field. And it was fun as hell, I'm going to tell you that right now. But anyway, that's a discharge. That is a discharge. A Zener diode waits until it has enough voltage to crash across the threshold, which is a PN junction, positive-negative junction. And it's got doping in it, which means there's molecules in there to say, no, you can't come through, and all of a sudden it hits 12 volts. All right, everybody come on through. 12 volts, if you're over 12 volts, come on through. It's like a guy standing at the doorway of a cafe saying anybody over 21 can get through here, and that's it. And that's what's happened here. And as soon as it discharges out, it settles down for a while. If you flood more electrons in, she's going to pop out. Sometimes you see them in clusters all over the place in these sprites. I'll show you some other shots.